Hello everyone and welcome to the second video of our DSA series. My name is Lenin Irungbam. So in today's lessons, we will be discussing about the introduction of time complexity and space complexity. And then we will learn why it's important to do the complexity analysis. And at the last, we will see some real world examples for better understanding. So before we started, have you ever noticed how some programs run faster than others? Or why some applications consume too much memory? So in this video, I will break it down for you in simple terms with real world examples. So keep in mind, as a programmers, we should make our code to run faster and use less memory. So that is where the complexity analysis comes into. It helps us measure how efficient our code is. So let's get started. So what is complexity in algorithms? Okay, so here you can see the definition. It is the performance measurement of an algorithm. Okay, it is important to understand how to measure the efficiency of an algorithm. Okay, when we write a program, we want our program to be faster and memory efficiency. Okay, so complexity refers to the how efficiently an algorithm performs in terms of time and space as the input size grows. So here we will analyze two main types of complexity. First is the time complexity and the space complexity. So time complexity measures how fast an algorithm runs, and the second, the space complexity measures how much memory an algorithm consumes. So understanding complexity help us to choose the best approach to solve a problem. So let's explore each of them in details. So what is time complexity? So here you can see the definition. It measures the how long an algorithm takes to execute as the input size grows. So you should remember this one, input size grows and how long. Okay, so as the input size grows, how long will it take to solve that program? Okay, that is the time complexity. Let's take one example. Imagine you have a you need to find a word in a dictionary. So there are two ways to do it, right? One is the slow method. So when you want to find a word in a dictionary, in the slow method, you have to search, means you have to find the word starting from the first page and look for that word one by one. Okay, in here you will take lots of time. So in the second method, the first method, what you can do is you can open the middle page and check if the word comes before or after, and then you can repeat the process, means you can open the middle again of the first half. So here it will be much faster. So the second method is more efficient because it reduces the number of steps needed to find a word. This is exactly what we do in programming. We want algorithms that run faster, especially when the input size grows. So let's move ahead, measuring the time complexity. So when we measure the time complexity, there are two key factors that needs to be considered. One is the number of operations performed, and the second one is as the size of the input data increases. So let's take one simple example. Say you have a 10 numbers. Okay, so 10 numbers means 0, 1, 2 up to 9. Okay, you have 10 numbers, and if you want to find a number 5, then you have to check each number one by one. So here it will be find, you will find the 5 numbers somewhere in here. What if you have 1 million. If you have 1 million, say 0, 1, 2, 3, up to 1 million. So if you check one by one, it will take lots of time. Okay, so clearly you can see that as the input size increases, the number of operations increases. Okay, so this means that the algorithm takes longer to execute. So what can you conclude from here? More the input size, okay, more time required. Okay, the more time required, so this gives more higher or more time complexity. Okay, you can say higher time complexity. Higher time complexity. So higher complexity. So what should be the solution for this? So we have to find an efficient algorithms so that we can reduce unnecessary operations. Okay, so you can see from this graph also, as the input size increases, the time also requirement also increases. So we have to consider why we need to pick a efficient algorithm so that we can reduce the unnecessary operations. So let's move ahead. We will see what is time space complexity. So in space complexity, you can see the definition. It measures how much memory an algorithm requires as the input size grows. Okay, so it tells us how much memory an algorithm needs to run. So let's take one example. When you want to go travel somewhere and you are packaged a suitcase. So first, let's say messy packing. So when you do the packing, the clothes, your belongings, if you randomly throw in the suitcase, then you might not able to fit all the clothes or your belongings, and somewhere it will waste some spaces. That is not an efficient way. Another method, neat packaging. If you fold and arrange the belongings neatly, then it will fit more in less space inside your suitcase. So that is a efficient way of memory uses, kind of. So in programming, bad memory usage can slow down your applications or it might crash. So so the same thing happens, okay, when a programmer uses too much memory. So that is the one thing you have to remember. We need to analyze the space complexity so that it makes your application run smoothly without any slowers down or causing the crash in your devices. So let's do see, why do we need analyze the complexity? Why is it so important? So let's see. First thing, it helps in writing the efficient code. So imagine two applications. Let's say application A and B. Okay. So application A runs for 1 second and it uses a minimal memory. Application B runs for 10 seconds and crashes on low-end devices. So which one will you prefer? Obviously, application A. Okay. So when you do the analysis, complexity analysis, we want our code to be more efficient so that it can run faster. Another thing is that it should optimize memory usage in applications so that it can avoid slower downs of your devices, as well as you can make memory uses efficiently. The third thing is that essential for the scale application. So as the scaling of for millions of users, say in Google or Amazon or Facebook, they should able to handle as the number of users increases. So by the end of this course, you will be able to analyze any algorithm efficiency and choose the best one. So let's see some real world examples of complexity. So first, let's see Google search. So when you type a query, Google scans billions of web pages in milliseconds. This is possible because of efficient searching and indexing algorithms. Second thing, in the navigation applications like Uber, Ola, Google Maps, how does this Google Maps find the shortest path instantly? So behind the system, behind the programs, they use graph algorithms like the Dijkstra's algorithm to calculate the best path. So let's see in the third e-commerce websites like the Amazon, Flipkart, okay, eBay. So how does the Amazon recommends product instantly? So they uses sorting and the recommendation algorithms that process massive amounts of data efficiently. So let's see in the again in the mobile games industry or applications, where you know the games needs to be fast and memory efficient so that they can run on different devices. So behind the applications also, they use efficient algorithm to process data quickly. So without proper time and space management, this application won't function smoothly. So let's summarize what we have learned today. First, time complexity we have discussed. So it measures how fast an algorithm runs. And the space complexity tells us how much memory it needs. And at last, we discuss about the complexity analysis. Why is it so important for optimizing the performance in the real world applications? So in our next lesson, we will dive deeper into the time complexity and learn how to measure it properly using the big O notation. So see you in the next video. Bye.